Dear students, Assalamu alaikum. Today our topic of discussion is Kirchhoff rules. Kirchhoff rules are major because whenever we want to describe the current and voltages in a circuit, we have to analyze the circuit using circuit rules. There are usual circuit rules. For example, when resistances are in parallel, then the equivalent resistance is sum of resistances, and so on. Similarly, equivalent resistance is sum of reciprocal of their resistance. If the resistances are in series, then the sum of resistances is equal, the equivalent resistance is equal to the sum of all the resistances, etc. So these are simple rules, but when circuit get complex, these simple rules does not work and are not helpful to calculate the resultant current or resultant voltage or resultant resistance or load impedance etc. of the circuit. So in order to solve such complex circuit, we need further rules. One of such rules are called Kirchhoff rules. There are two type of Kirchhoff rules. First is the Kirchhoff first rule, or it is also called Kirchhoff current rule, or it is called Kirchhoff's mesh rule, or sometimes it is also called the Kirchhoff's point rule. Because currents are involved in this rule, this rule deals with the currents in the circuit, or this rule is about the currents flowing in the circuit, so sometimes it is called current rule. Because uh, the statement about the currents is at a point or at a mesh means some point like this where two or more branches of the circuit meets is called a mesh, or a point rule. In the same sense, the point rule is that at any point in a circuit, sometimes uh, this described as a point rule, sometimes mesh rule, sometimes it is called current rule or Kirchhoff first rule. But whatsoever will be the name, you should recognize it. But in your text, this would be most appropriately, or in your examination, it will be called Kirchhoff first rule. So you should uh, keep in mind that what is meant by Kirchhoff first rule. As I told you that Kirchhoff first rule is according to the current. So it says that the sum of all the currents meeting at a point. All the currents meeting at a point in a circuit is zero. What does this mean? This means that whenever there is a circuit, whether it is a simple or a complex circuit, then uh, if you consider a point in a circuit, then at that point, the sum of all the currents meeting at that point means we know that whenever we consider a point, for example, we consider a circuit, and here is a circuit, a very simple circuit in this way, for the sake of simplicity. This is very simple circuit. And here is a point which we consider as a mesh point, or a point at which we want to talk about the current. According to this rule, the sum of current are meeting, of all the current meeting at this point. For example, if a current I flows from this point towards this point, then and current I2 flows away from this point. So this is the sum of currents meeting at that point must be equal to 0. That is I1 plus I2 is equal to 0. Okay. And now I am telling you that current I1 plus I2 is equal to 0. What does this mean? This means that I1 is equal to minus I2. What does this mean? This means that the current flowing towards a point, if taken as positive, then the current flowing away from the point is taken as negative. So, so we are now in a position to understand the meaning of this. Uh, uh, as an example, here we consider a circuit, a point at a circuit. There are four resistances and four circuit branches meeting at a point A. And suppose that two currents I1 and I2 flows towards this point, and two currents I4 and I3 move away from this. We usually use the convention, if we take the current flowing towards the point positive, then current flowing away from the point are taken negative. So in that case, we can say that the sum of all the currents flowing towards the point is 0 can be mm, written as I1 plus I2 plus, according to our convention, the current flowing away from the circuit are taken negative. So I3 is negative plus I4 is also negative. According to Kirchhoff rule, the sum of these currents is equal to 0. This implies that I1 plus I2 is equal to I3 plus I4. So this is the sum of current flowing towards the point. This is the sum of current flowing away from the point. So in other words, we can also state the Kirchhoff first law that sum of currents flowing towards the mesh point, towards the point in a circuit, is equal to the sum of currents flowing away from the circuit. So in both of these statements, we can say that the sum of all the currents meeting at a point is equal to 0. Kirchhoff rule is actually the law of conservation of charge. So here the statement is that the Kirchhoff point rule is the manifestation. Manifestation means that whenever we apply some law to the circuits, why this law works. So the working of this law for the present case is due to a fact of nature that the total charge is conserved. What does this mean? This means that the total charge flowing towards the towards a point is equal to the total charge flowing away from the point, away from that point. In the sense of this is called manifestation. Manifestation means to to express themselves. Manifestation means to express express itself. So the law of conservation of a charge is actually the uh, manifest itself in the form of Kirchhoff point rule or Kirchhoff first rule. What does this mean? This means that if there is no source or sink, source mean which can produce the charge, sink mean which can destroy the charge or absorb the charge at a point. What does this mean? This means that if there is no source and sink of charges at a point, then the total charge flowing towards the point must be equal to the total charge flowing away from the point. So this is called law of conservation of charge. So this is what is about the law of uh, Kirchhoff first rule. And now the second rule is Kirchhoff's second rule, which is most important as a long question for examination point of view. But you can say that it is the most important topic for the chapter 13. It is frequently asked, but usually both these laws are asked in examination, state and proof Kirchhoff rules. But in particular, one Kirchhoff rule can also be uh, stated, can also be asked in examination. That is Kirchhoff's second rule. Kirchhoff's second rule is also called Kirchhoff loop rule because it it is applied to any loop in a circuit. Also, it is called voltage rule because it is about the voltages or potential changes in a circuit. Statement. This law says that the algebraic sum means their magnitude will be added according to usual algebraic rules. The algebraic sum of voltage changes in traverse mean in moving along the loop. For example, if a loop, we consider a loop, this loop is like this. So this is a loop in which there are two resistances R1 and R2 and a battery M of EMF E. So this is a type of loop. This is the loop, and traversing a loop means from this loop we start from one point of this loop and move and come back again to that point. So this is called traversing of a loop. Or a closed circuit is zero. What does this mean? This means that when we traverse this loop, uh, this loop, the traversing of this loop is actually mean when we move from one point and go around the loop and end at the same point that we have started from. Now, or you can also state it in some simple uh, uh, way, that is algebraic sum of potential changes. These voltage changes or potential changes in a circuit, in a total circuit, is also zero. Proof. In order to prove this law, we consider a circuit as shown in figure. In this circuit, there are two things. There are two resistances and there are two uh, EMF sources. So this is not very much complicated circuit, but it it is kept simple in order to illustrate the points. So there are two EMFs, E1 and E2, and there are two resistances R1 and R2. First of all, when we want to apply the Kirchhoff's second rule, we must consider a loop. For the present case, this loop is in this form. But in the second step, we have to consider the direction of current so that we can talk about the energy gain or loss by the charges due to the flow of current. And for the present case, we assume that the voltage E1 is greater than EMF E1 is greater than EMF E2. So if EMF E1 is greater, and then what does this mean? This means the positive terminal of E1 is at high potential to the as compared to the positive terminal of E2. Please keep in mind this thing whenever we say that some EMF source or some EMF some battery of EMF some battery has greater EMF. What does this mean? This means that the positive terminal of that battery, a battery which have positive terminal of that battery is at high potential as compared to the battery whose positive terminal which is taken as of lower EMF. So now come to the point after having some sort of understanding for this circuit. Now we come to the point. The first thing we should keep in mind that what is meant by when a steady current flow through the circuit. When we say that the steady current flows through a circuit, this is equivalent to the continuous flow of charges. This is equivalent to the continuous flow of charges. Means steady current mean continuous flow. There may be a flow of charges which may be instantaneous, but here we assume that a steady current flows through a circuit. This means that a continuous flow of charges uh, is taking place along in the circuit. And then the second point we must keep in mind that when we say that uh, what is potential change or potential difference. These are all concepts already discussed in detail, but again we want to say about the meaning of this. The voltage change or the potential difference. You should keep in mind that whenever we say that potential difference, there are 2 points. And whenever we say the potential change, voltage change, this again means there are 2 points, and the voltage at one point and the voltage at second point. And when we move from one point to another, then the voltage change in that point. Then what does this mean? What does this mean? This means the voltage and potential difference is equal to. This is very important concept. Is equal to the work done on unit positive charge. Unit positive charge moving between these 2 points. This is the basic concept about the voltage change or potential difference. Are any energy and second concept associated with it is that the voltage change or potential difference between 2 points is also equal to the energy gained or lost by the charge. When a charge moves between these 2 points, the energy gain and lost by the charge and moving between those points is also equal to the potential difference or voltage change. These are two basic concept which you must have in mind in order to understand what is going on. So this is very important concept. I hope you have understood this concept. Now we want to apply this concept to prove this charge. Suppose when steady current passes, steady current I passes through, and the charge flowing through the circuit is delta Q. Suppose a small charge delta Q passes due to this steady current uh, uh, passes through E1. Now, let me first tell you about the direction of a current. If we assume that the EMF E1 is greater than EMF E2, then as I told you that the positive terminal of E1 must be at greater potential as compared to the positive terminal of E1. So we always know that current always flows from high potential to low potential. So in that case, we can say that the direction of current is clockwise, anti-clockwise. in the circuit. The meaning of clockwise or anti-clockwise is according to the view, as we view according to the viewing uh, of some circuit or loop in front of us, just as we say a clock on the wall. So if this this EMF E is greater than E2, then the current is anti-clockwise. So from now on, I explain this fact that whenever you want to guess about the direction of current in a closed loop or in a circuit, if you are sure about the EMFs, which EMF is greater than other EMF in a single loop, then you can guess the direction. But you should not worry about the direction of current in each loop. You can imagine, you can assume any direction, either clockwise or anti-clockwise. The original direction or actual direction of the current will be decided by the resulting current or the results of the uh, uh, resulting current of the circuit. For the time being, it is a single loop, and this single loop is not much more complicated. And just by assuming that EMF E1 is greater than E2, we can find the direction of current. But you should not worry about the direction of current. It may be considered any direction, and the correct direction will be decided uh, after finding the resultant current in the circuit. Now, after deciding the direction of current, now we want to find the voltage changes or potential differences, because if we go to the statement, this statement says that the algebraic sum of potential changes. This means that whenever we want to describe the circuit with the help of Kirchhoff's second rule, or we want to apply the Kirchhoff's second rule to some circuit or a loop, we must know the potential changes or potential differences. But for the present case, we are going to prove that the algebraic sum of potential changes in a circuit is zero. So the procedure or method to attack the problem may be some tricky. In this case, we assume that when current I flows through the circuit, and as a result, from this fact, we know that the flow of current means flow of charges. So for the present case, we assume that when delta Q charge passes through the EMF E1, when current through the circuit is I, and this, if suppose that this current flows from low potential to high potential. This, what does this mean? This means that now we started in the traversing this uh, circuit, this closed loop from the negative terminal of the battery E1. So we started from the negative terminal of the battery E1. As we started from this and go from negative terminal to positive terminal, what does this mean? This means that negative terminal mean at low potential and positive terminal mean at high potential. What does this mean? This means that we move from low potential to high potential. And whenever we know that whenever we move from low potential to high potential, we must supply the energy to the positive charge. If this is positive plate which is at higher end, this is negative plate which is at low potential. So we know that whenever we want to move the charge from low potential to high potential, we must have to do work, and this work will store in the form of electrical potential energy. So using this fact, we say that whenever we move from low potential to uh, high potential, energy is gained. So in that case, due to this reason, we have written here that energy is gained. And this energy is due to work done, as I have told you. So gain in energy is E1 delta Q. This is again the same uh, relation which I have told you in case of potential energy, that delta U is equal to the potential difference delta V multiplied by the charge moving through between these two points. So same concept is used here in case of energy gain. Similarly, now we come to the mm, uh, EMF E2. In case of EMF2, this the flow of direction of flow of current will guide us that whether we are going from high potential to low potential or low potential to high potential. And according to the direction of current, then the charge move from positive terminal of the battery to the negative terminal of the battery E2. What does this mean? This means that the charge is moving from high potential to low potential. As we move from high potential to low potential, there is loss of energy. And what amount of loss of energy for the present case is E2 delta Q. In order to distinguish between energy loss and energy gain, we use symbol. Actually, we may make a convention that loss of energy is negative and gain of energy is positive. And then now we will mm, go to the uh, case go to the case of resistances. In case of resistances, we know that the current is always flow from high potential to low potential. What does this mean? This means that when current flows through the resistance R1, it always loses energy. So it is negative. But this loss of energy must be taken as negative. And what is the loss of energy? Again, the potential difference uh, resistance is equal to uh, IR, and this is according to this Ohm's law. And the charge flowing is this. So we can see that we can write that energy loss through the in traversing the charge from R1 to R through R1 is I1 IR1 delta Q. Similarly, again charge move from low potential to high potential in case of R2. So this is again I R2, and this will be negative. And according to Kirchhoff voltage rule or Kirchhoff second rule, the sum of according to law of conservation of energy, law of conservation of energy. If there is no sinker source, then the total change in energy must be equal to 0. So change in energy in traversing the current through EMF E1 is, and change of energy in traversing through EMF E2 is E2 delta Q, and in traversing through resistance R1 is minus IR1 delta Q, IR2 delta Q. It must be equal to 0. Change in energy is 0 because law of conservation of energy, there is no source or sink in this source of energy or sink of energy in this uh, circuit. So the total change of energy around the closed loop must be equal to 0. So delta Q is common and can be taken to out. But what is this? This is a voltage change. This is also voltage change. This is also voltage change. This is also voltage change. Or you will look at potential difference. And here we see that the potential difference of all the potential differences across the in a closed circuit is equal to 0. So this is what is called law of second Kirchhoff rule. Second Kirchhoff rule is also the manifestation of law of conservation of energy. Conservation of energy. Because in this case, potential change, as we already seen that the potential changes are actually due to the flow of current, there are taken changes in energy. And when we apply the law of conservation of energy, we arrive at the conclusion that the potential changes or potential differences traverses in a closed circuit is equal to 0. So we can see that Kirchhoff's second rule is manifestation of law of conservation of energy when applied to the electrical circuit. You can uh, say that why this sort of rule over here. If we want to apply the law of conservation of energy, we should apply the law of conservation of energy as usual. Total energy changes must be equal to 0 in the absence of source or sink, or total energy of a system remains constant. We can directly apply this. Actually, we have directly applied this law of conservation of energy here. But this law of conservation of energy, when applied, results into this equation. So this is all about the second Kirchhoff law. I hope you will always you have understood the things. So now we are going to leave this meeting.